In this video, I'll be using augmented matrices to solve a system of equations. Basically, we're using row operations here, and we're going to write this new matrix in what we call row echelon form. And at the end, I'll show you reduced row echelon form. But we're going to use that to solve the system. And so this is how that's done. This is referred to as Gaussian elimination. So first of all, let's go ahead and write the matrix here. And you can see that, well, first of all, we want to have our matrix in the following form. So let me write that at the top for you. So we want to have this form where we have ones on the main diagonal, zeros, below the ones, and then numbers elsewhere. This is what we call row echelon form. Now, if I had zeros above the ones, we would call that reduced row echelon form. All right, so basically what we're going to do is we're going to put this matrix into row echelon form, and then we're going to use back substitution to solve the system. All right, so let's go ahead and do that. So I've already got the 1 that I want in the upper left-hand corner. This is always our starting point. And then we want to use that 1 to get zeros below. So I need zeros down below the 1. And so we'll use that 1 to obtain that, or to get that. And so I'm going to multiply the first row by -2. And if I add that to row 2, that'll give me my new row 2. And I'm going to multiply the first row by -3 and add that to row 3, and that'll give me my new row 3. So let's go ahead and get started. So let's multiply the first row by -2. -2 times 1 is -2. Oh, I'm sorry. I've rewritten the matrix. The first row isn't going to change, so I've gone ahead and put in the first row. So rows 2 and 3 will change. So now let's go ahead and multiply the first row by -2. We're going to get -2. 2 times -2 is -4. -1 times -2 is 2. And 3 times -2 is -6. And now we'll go ahead and add what we just got here with row 2. So we're adding -2 times row 1 to row 2. And so we're going to get 0 when we add -2 and 2. -4 and 7 is 3. 2 and -8 is -6. And -6 and 15 is 9. Now, let me go ahead and erase what I just got there, because I'm going to need that space. And now let's multiply by -3. So -3 times 1 is -3. -3 times 2 is -6. -3 times -1 is 3. And -3 times 3 is -9. And so when we add, now we're adding -3 times row 1. That's just what we just got. We're going to add that to row 3. Notice we will get the 0 that we want in the first place. -6 and 7 is 1. 3 and a -2 is 1. -9 and 6 is -3. And so notice we've got our zeros below the 1s, so we've taken care of the first column. Now we're going to move down the diagonal, and we want to change that 3 to a 1, or we need a 1 in that position. Now you could switch rows 2 and 3 and get the 1 you want, but it'd also be quite easy to just divide by 3. Notice all of these numbers are divisible by 3. So again, instead of writing it as division by 3, we'll write it as multiplication by the reciprocal, which is 1/3. So, oops, I wrote -1/3. Why did I do that? Let's see what I did. So, we really want to multiply by 1/3. Let me fix that. We're really dividing by 3, so 0 divided by and actually let me go ahead and put in that last row. The only row that's changing is row 2. So 0 divided by 3 is 0. 3 divided by 3 is 1. Negative 6 divided by 3 is negative 2. And 9 divided by 3 is 3. Okay, so now you can see we got the 1. Oops, wrong button. We got the 1 we wanted here. Now we want to use that 1 to get a 0 below. Well, that'll be pretty easy. We just need to multiply equation 2 by negative 1, or it'll be negative row 2 added to row 3. And if you wanted to put a negative 1 in there, you could. So I'm going to just basically change all the signs. Let me go ahead and write in the first 2 rows. Those aren't going to change. And let's see, all of our signs are going to change. Well, you're not going to make 0 negative. It'd still be 0. So this will be negative 1, positive 2, and negative 3. So negative 1 and, well, first of all, 0 and 0 is 0. Negative 1 and 1 is 0. 2 and 1 is 3. And negative 3 and negative 3 are negative 6. Okay, so we got the 0 that we wanted here. And so now we're ready to move down the diagonal to the next number. And we need to get that 3 to become a 1. So again, we've got our 3-row operations here. I'm noticing 3 and negative 6 are both divisible by 3. So let's go ahead and multiply by a third times row 3, and that'll be our new row 3. Again, that's equivalent to saying we're dividing row 3 by 3. And so let's go ahead and do that. The first row and second row don't change. 1/3 times 0 is 0. Same thing here. 3 divided by 3 is 1, and negative 2 divided by 3 is negative 2. And so notice we have this in this form, a row echelon form. It's not in reduced row echelon form because of the fact that we don't have zeros above the ones. So I'll come back at the end of the next video and address that. But for now, let's go ahead and write this as a system. So we have x plus 2y minus z is equal to 3. Y minus 2z equals 3. That's from the second row. And then z equals negative 2. And so again, this is where we're going to use back substitution. This system now is much easier to solve than the original one was. So we're going to replace z with negative 2. We get y minus 2 times negative 2 is equal to 3, or y plus 4 is 3, which means y is negative 1. And so let's go ahead and plug y and z into the first equation here. We'll get x plus 2 times negative 1 minus negative 1, or I'm sorry, z is negative 2, so minus negative 2 is equal to 3. We're going to get x minus 2 plus 2 equals 3. Of course, negative 2 plus 2 is 0, so we're just going to get x equals 3 here. And so our solution is the point 3, negative 1, negative 2. This is a consistent system since we have at least one solution, and it's also independent. And I do want to point out how easy it would be to check this answer if you wanted to go back and do it. You can just, in the first equation, you would put 3 plus 2 times negative 1 minus negative 2, and when you hit enter, you should get 3. So you can actually either do the math in your head or check it on a calculator, but literally in less than a minute you can check your answer and know that you did it right. Okay, let's move on to number 13. Now I would encourage you to see if you can do number 13 and then watch the video. Now keep in mind there's not one way to solve a system. Like for me, I think you're probably going to want to let's go ahead and get started here. We can write this as a matrix, and you can see that it makes sense to flip the first 2 rows to get the 1 where you need it. But once you get to this point, I think there's certainly going to be sometimes students may choose to go a different route than what I did, and that's fine. There's more than one way to solve these. We're just trying to keep it as simple as we can. All right, so go ahead and see if you can solve that, and then I would encourage you to watch the video. All right, so let's start by multiplying. See, we already have the 1 we need in the upper left-hand corner, so we want to use that 1 to get zeros below. And so let's go ahead and do that. We'll need to multiply the first row by -2 and add that to row 2, and that's going to become our new row 2. And since we have a -5 in this first position in row 3, we're going to want to multiply the first equation by 5 and add that to row 3, and that's going to give us our new row 3. So let's go ahead and get started. I'm going to rewrite the, oh, I guess I didn't. Let's go ahead and multiply each of the first, each element in the first row by -2. We're going to get -2, -4, -6, and -8. Now let me go ahead and write the matrix with the first row, since that's not going to change. And let's go ahead and add these 2 times the first row to the elements in the second row. We're going to get -2 and 2 is 0. -4 and -1 is -5. -6 and -4 is -10. -8 and 3 is -5. Now let me go ahead and erase what I have here, because I need to multiply everything by 5 now. And so 5 times 1, we're going to get 5, 10, 15, and 20 here. And so now we can add these together. 5 and -5 will get 0. 10 and 3 is 13. 15 and 1 is 16. And 20 and a -17 give you 3. And so notice we've taken care of the first column. So now we want to move down the diagonal. And we need a 1 right there where that -5 is. Now notice if we divided that whole row by -5, we would get the 1 we need. So let's multiply by the reciprocal, -1/5 times row 2, and that'll become our new row 2. So I'm going to go ahead and write the matrix with the first and the last row, since those aren't going to change. And let's go ahead and basically divide by -5 in the second row. Now 0 divided by -5, that's 0. -5 divided by -5, of course, that's 1. -10 divided by -5 is 2. And again, -5 divided by -5 is 1. And so now that we got this 1 here, we're going to want to get 0 below and use the 1 we just found. And so let's go ahead and do -13 times row, that should say 2. Let me fix that. And we're going to add that to row 3, and that'll become our new row 3. And so notice only row 3 is going to change, so I'll rewrite the matrix with the first 2 rows. And let's see, I need to multiply the second row by -13, so I'll get 0, -13, -26, and -13. And now let's add these red values to the third row. So -13 times row 2, we're going to add that to row 3. 0 and 0, we get 0. Of course, -13 and 13 is 0. -26 and 16, that's going to be -10. And -13 and 3 is -10. And so finally, we got our 1 and our 0 in the second row. And we need to go down the diagonal, and now we need a 1 here where the -10 is. And so we can divide the last row by -10, or again, we'll multiply by the reciprocal. It'll be -1/10 times row 3. That's going to become our new row 3. So I'll write in the first 2 rows. And when we divide by -10, we'll get 0, 0, 1, and 1. Now, you can see we've done a lot of work already. And at this point, we're going to stop because we have this in row echelon form. But keep in mind, if we wanted to continue, we would change these three values here to zeros and get this into reduced row echelon form. And so that's our other option, but we're going to use back substitution at this point. So let me write the system here. We got x plus 2y plus 3z equals 4. That's from the first row here. And then y plus 2z equals 1 and z equals 1. And so again, we'll use back substitution. Let's substitute 1 in for z into the second equation. We get y plus 2 times 1 equals 1, or we're going to end up getting negative 1 there. And then we'll plug in 1 for z and negative 1 for y into the first equation, this one here. And we'll get x plus 2 times negative 1 plus 3 times 1 is equal to 4. That's x minus 2 plus 3 equals 4. Of course, a minus 2 and a plus 3 is 1. We get x plus 1 equals 4, which means x is equal to 3. So our solution here is 3, negative 1, 1. All right. So let's go ahead, and we should also write this as consistent and independent. And let's see, what do we have here? We're going to stop right here. I think that'll be the end of this video, and I'll make one last video where I cover two special cases for equations where you have three variables, or three equations and three variables. And then I will probably do either 12 or 13, the two problems I just did. I'll continue on and show you how you can use or get your matrix in reduced row echelon form as another alternative to what we just did here, where we used back substitution. All right, so that's it for this video.